Welcome to Tutor-E's Chemistry Hub, where we'll do our very best to make science as simple as it can be. And today we are continuing our discussion in stoichiometry. We have looked at mass to mass stoichiometry. We have looked at mass to volume stoichiometry with respect to gases. But in this case, we'll be looking at mass to volume stoichiometry with respect to solutions. Now, when you are dealing with gases, that is when you use molar volume. But in this case, when it refers to solution, we will not be looking at molar volume because we are not dealing with gases. And that is why it is very important to be able to differentiate all these situations. And in this case, one of our most popular formulas today is going to be the fact that concentration is equal to the number of moles divided by volume. As you can see, we are giving concentration and we are giving volume. So in such situations, when it comes to a solution, you don't think of molar volume. Instead, this is the formula that should come into your mind. So it will be our most used formula today. However, as we always do, the first thing, let us get the equation of reaction. We have the reaction between ammonia and hydrochloric acid. Now we are used to the fact that when acids react with bases, we get salt and water only. But I guess you can say this is one of those exceptions. Ammonia is a base, hydrochloric acid is an acid. However, we don't get salt and water in this case. It is still neutralization. We only just get the salt, which is ammonium chloride. And if you check our equation in itself, it is actually balanced. So we simply move on and check out what do we need. What are we given? We are given 50 milliliters and the concentration of ammonia. That means you are dealing with ammonia. Now you can see in this case, we are told that hydrochloric acid is in excess. The beauty of it is that in our next video, we'll be looking at limiting reagents. We'll talk about limiting and excess. And remember, you work with limiting reagents because that is what determines the amount of products. In this case, I already told hydrochloric acid is in excess. That simply means that ammonia is our limiting reagent. So that is what is going to determine the amount of products. So in other words, and we are determining the mass of ammonium chloride produced. So we are going to deal with ammonia and ammonium chloride. So as usual, we simply have ammonia and we have ammonium chloride. Now, because we are given concentration and the number of moles which we will get because we are given the volume, all we simply just do is we can calculate it using mole ratio. So from our question, 1 mole of ammonia produced 1 mole of ammonium chloride. So what do we now do? How many moles was given in the question? We're not given the number of moles, but because we are given volume and concentration, we can get it. So we know that concentration equals number of moles divided by volume. So therefore, number of moles will actually be concentration times volume. That simply means that the number of moles of ammonia is going to be 0.75 times. Now again, you need to remember that your volume should always be in liters. We spoke about it, that we have decimeter cube, we have centimeter cube, and decimeter cube is also liters. So you may be seeing it as mole per dm cube, or you may see it as mole per liters. Either way, you are practically saying the same thing. Now, 1000 liters makes 1 milliliter. So that means if you are converting milliliters to liter, you simply divide by 1000. So that will be 50.0 divided by 1000. So our answer simply becomes 0.375. So according to the question, what you are given is actually 0.375. 0.375 moles of ammonia. So our work becomes very easy. 1 mole of ammonia produced 1 mole of ammonium chloride. So therefore 0.375 moles of ammonia will produce X of ammonium chloride. When you simply cross multiply, X times 1 equals X. 0.375 times 1 is 0.375 moles of ammonium chloride. That would have been our answer, but the only thing is we are asked to calculate the mass of ammonium chloride, not the number of moles. So how do we get the mass? Remember our simple formula that mass equals the number of moles times the molar mass. So our mass will be equals 0.375 times the molar mass of ammonium chloride. Let's calculate it. Again, depending on the curriculum, the values can differ, but most times nitrogen is 14, hydrogen is 1, but there are 4 atoms of hydrogen. 1 times 4 is 4, plus chlorine is 35.5. So when you add this, you are going to be having 18 plus 35.5. I think that should be 53.3, but let me confirm. 53.5, sorry. Yeah, so you'll be having 53.5 as the molar mass of ammonium chloride. So that becomes 0.375 times 53.5. So once you multiply, you are going to have M equals 20.0625 grams. And that is your answer. So you can see it's quite simple. From your concentration, get the number of moles. As usual, extract what the equation gives to you. Then calculate what you need. But remember, we're not talking about number of moles. The question requires us to get the mass. So we simply solve and get the mass. Alright, so let's do exactly the same thing for question number 2. Now this is a reaction between sodium hydroxide and phosphoric acid. Again, you can see in the question, we are told that phosphoric acid is in excess. So our limiting reagent is sodium hydroxide. That means sodium hydroxide is what we are going to use to make our calculations. Now in this case, an acid reacting with a base will give us salt and water. Always remember, you need to get their proper formulas. Check out my previous videos on balancing chemical equations. You will see in some cases, we spoke about getting proper formulas. So we get sodium phosphates and water. Again, just as a reminder, sodium, the oxidation number is 1, or some will say valency. And phosphate ion, it is 3. So once you swap it, it is Na3PO4. The 1 affects it all. But because it's just 1, it makes no difference. So simply write Na3PO4. That is our answer. So the next step is to check if our equation is actually balanced. You check it out, it is actually not. There are 3 moles of sodium. So we have 3 moles of sodium here. And then we should be having 3 moles over here. Again, to balance chemical equations, check my previous videos on how to balance chemical equations. But if you check it out, 3 moles of sodium, 3 moles of sodium. We take PO4 as a single unit, which is 1. We take PO4 here as single. Then 3 moles of oxygen, 3 moles of oxygen, 6 moles of hydrogen, 3 plus 3, that's 6 moles of hydrogen. So again, check out the video and you get exactly how to do it. Once again, our limiting reagent is sodium hydroxide, and we are asked to calculate for sodium phosphate. Sorry. So we simply go exactly the way I've been doing it since. 3 moles of sodium hydroxide, and we are dealing with sodium phosphate. So now we simply get the number of moles. Sodium hydroxide is 3 moles, and in this case, it is 1 mole. Then the next thing we simply have to do is, because we are given concentration and volume again, it is easier to get the number of moles. And you can remember, having used the formula, we know that number of moles equals concentration times volume. And always remember, our volume needs to be in liters, not in milliliters. So therefore, the number of moles becomes 0.50 times the volume, which is 100 milliliters, divided by 1000, in order for it to be in liters. So once you do this, I think this is easier in this case. 100 divided by 1000 is 0.1. 0.1 times 0.5 will give us 0.05 moles. That simply means that, remember, this is referring to the number of moles of sodium hydroxide. Let's just put it sodium hydroxide. That's what we were given in the question. So therefore, if 3 moles produce 1 mole of sodium phosphate, 0.05 moles of sodium hydroxide will produce X. In this case, we cross multiply. We have 3X equals 0.05 times 1 gives us 0.05. So X becomes 0.05 divided by 3. And when you do this, you'll be having 0.1667 moles. Again, remember the question. It says calculate the mass, not the number of moles as you have gotten now. So let's get the mass of sodium phosphate. Mass equals the number of moles times the molar mass. So the mass will therefore be equal to 0.1667 times the molar mass of sodium phosphate. Again, most times you will be given these values, but just in case you are not given, it is good that you learn them and know them by heart, at least for the most popular elements. An example, we are looking for the molar mass of sodium phosphate. Sodium is 23. 23 times 3, that gives us 69. Phosphorus is 31. Oxygen is 16 times 4, that gives us 64. So when we add them up, 69 plus 31 will give us 100, and 100 plus 64 will give us 164. So it is now 0.167 times 164. So when we multiply this, it gives us 2.73 grams. And that is the mass of sodium phosphate that will be produced. That is exactly how you make such calculations. Now, looking at this question number 3, it is practically similar and the same thing. However, if you look at this case, we are dealing with a neutralization reaction here. Exactly the same pattern is going to follow, the same way of solving, but just like in this case, in both cases, we are given volume and we are asked to calculate concentration. So we are still going to use the formula number of moles equals concentration times volume. However, there are 2 methods that can be used to solve this. So watch out for the next video where I solve this question using both methods. In one case, we'll be using stoichiometric calculations as we are having now, writing the chemical equation and extracting the number of moles and all we need. But then we can also solve it like volumetric analysis, where we just use the mole ratio or the acid and the base and get the exact values that we want. So watch out for the next video. But in the meantime, practice and be able to know how and when to use these values. When it comes to volume, there's a difference in aqueous solutions, as I have done now, and different from gases, where you use the molar volume. And then there's the mass to mass. So as usual, always remember to like, share, and subscribe.